Okay, week 6 now. We went through the homework assignment, went through the in-class. We're on a new one. We're on, matter of fact, let me open this up right here. Let me show you this. Here we are. Here are your 3 approaches. Here are your 3 equations. Our homework we just got finished with is this, taking the mean with the sample standard deviation using T. This week is all about proportions, where there's no standard deviation in the story. It's all about this 3rd equation now. This is the last of the 3 equations. That 3rd equation is right here in words. The sample proportion minus the hypothesized proportion, just like the other ones. The last 2 weeks have been the sample mean minus the hypothesis mean. This week, same situation, but it's proportion. Sample proportion minus the hypothesized proportion. Over. Now here's the tough part. You gotta remember this square root goes over the whole thing on this proportion problem. The square root is not over the numerator of this part. The square root is not over the sample size like the other 2 equations. It's over this whole denominator. The square root's gotta go all the way down. The hypothesized proportion times 1 minus the hypothesized proportion over the sample size, then you square root it. Then you divide it into the numerator. That's the order of operations you got to go in to get this right. So there it is in words. Here it is on the PowerPoint. Oop. There it is in letters. That P right there stands for sample proportion. That little symbol there stands for hypothesized proportion. So there it is using symbols. If you'd rather have the symbols, I'm on slide 16. So you have the proportion formula there. Now I want to make sure, there's something I want to make sure you understand. Sometimes the proportion's not given to you in the story, that you have to calculate yourself. And it might say something like, 100 people were surveyed and 45 said this. 45 divided by 100 gives you your proportion. Whatever the word success and failure, as you read a little bit about this in the PowerPoint, you read a little bit about this in the book. The word success is whatever it is we're measuring out of the sample size. So if there's a survey of 100 and 45 said they're going to vote yes, the success is that we're measuring how many said yes out of the sample. But we could be measuring those who said no. Then if we're measuring who said no, that's the success. Proportions are however many out of how the sample size are the successes that we're counting. The failures are the ones we're not counting, those who didn't answer the survey yes or didn't answer it no, whichever way we're going. So I don't want you to get confused when you see success and failure. Success means however many we're counting that we're measuring out of the sample size to figure out the proportion. I think I got an example ready, but I don't think it's this first one. So here's the deal though. Here's the deal with proportions. I'm going back to this equation right here. This is the main equation to find your z. We're back to z because there's no standard deviation, it's a proportion. But we have to be able to solve proportions just like we did with the population standard deviation, the sample standard deviation. We have to solve this with all 3 approaches. We have to be able to use p-value, we have to be able to do critical value, and we have to be able to use confidence intervals. And you got to be ready for all 3, and let me explain why. Look at this. Week 6 homework, jumping right to the bowl. Solve this using the p-value approach. That's number 1. Let me go to number 2. Right there in bold. Solve this using the critical value approach. There's number 2. Let's go to number 3. Solve this using the confidence interval approach. So now you're right at the point where you're experiencing what a quiz question is going to look like. Because it's going to, not only you have to figure out which equation to use, do I have the population standard deviation, the sample, or no standard deviation, but you need to make sure and read which approach to use also, p-value, critical, or confidence interval. So you've got to read the directive. I can't believe how many points you're going to go, oh my God, I got this all done. I know I got the right answer, and you forgot that you were using the p-value approach when it was asking for the critical value approach. The amount of points you're going to lose is huge. So you got to make sure and read which approach to use. And so this homework that's due a week from today is preparing you exactly for that. Because you have to do, each approach is on there. And if you do the wrong approach, you'll lose too many points. So this is a perfect example. So, now, I'm going to start with our first example right here. This is a great example because I had something like this in real life where I was able to use this. This is a very good example. And I want to be able to solve this using all three approaches, so we are familiar with proportions using all three approaches, so that when you do the homework, you're gonna know how to do every problem based on which approach you use. Here it is, a marketing company claims that they received 8% responses from a mailing. I can't tell you how many businesses I was involved in. I was president of a small computer company before I semi-retired and decided to go teach. And when I was working for this computer company, I literally had a marketing company come up and try to sell me on, hey, we do these mailings, and if you put a coupon on the mailings, you'll know exactly then how many people responded to this mailing. And that's kind of a way to count it. And they're saying, and they show me maps with all these different zip codes. And you can hit all these zip codes that are in the area of your particular business, and it will be, gosh, it was like 30,000, 20,000 mailers maybe. And the price was, I don't know how much, it was less than $1 for each one. It was way less than $20,000, I remember that. And I think it was less than 50 cents even for each one. So, but the more you did, it was the smaller the price is for each one you do. They want you to commit to thousands of dollars just to do this mailer and see what kind of response you get by giving a coupon. So what I said is, look, before I'm gonna spend this kind of money, you guys are just telling me I'm gonna get 8% response. I wanna see if this is true or not. So let's just do a few in a couple of zip codes. Let's just do a sample of, and this is a perfect example, this one's saying, let's do a sample of 500 and see what kind of response we get. I tell you what, if I get an 8% response, then yeah, I'm probably gonna go, we'll do the rest. But if I'm not getting 8% response like you're telling me I should be getting, then I don't think I want to spend this kind of money. Or you need to either lower your price to get my business, or I don't think I'm gonna want to do it. So this is a perfect example where they're gonna be willing to do this because they want your business so bad. Hey, look, at least we're getting 500, how can we not do this? So they go ahead and send out 500, and they get 25 responses. Now here's a perfect example where you gotta come up with the proportion yourself. The 25 responses is the success, and this makes sense because getting 25 people to come to the business and show you they're going to use this coupon because they got this mailer, that is a success because at least you're getting someone to respond. But what percent is that? Anybody got a calculator? 25 divided by 500, what's that going to be? 0.05?
Yeah.
0.05, so I can get started here, 0.05 minus, they're telling me I'm going to get 0.08, so I already know that's going to be my hypothesis. I should have wrote it. Now here it is, H sub O dot proportion. We're not writing mean now. At least put a P. Okay, don't put mean. This is a proportion. Is this one tail or two tail? I forgot. We're trying to prove it's 8%, or we're trying to prove it's less than or greater than. How's the story read here?
It's two tail.
It's two tail because it doesn't say specifically that we're trying to prove it's less than 8%. Doesn't say we're trying to prove more than 8%. We're just trying to test whether it truly is 8%. So this is two tail. Proportion equals 0.08. The null hypothesis, proportion is not equal to 0.08. Don't forget, the number has to always be the same in your both hypotheses. You're never gonna have two different numbers in this class. Don't get me wrong, there are some in real life down the road if you had advanced. So now, here's our hypothesis. Now with proportions, there's one more thing you're supposed to test, but I want to tell you right now, you don't need to focus on what I'm about to tell you because I am not going to try to fool you on quiz. I'm not going to try to fool you on the final exam. This will always be true with a problem I'm giving to you, but you are in real life supposed to test this. And what you're supposed to test is this in a proportion for this to work, for you to be able to use p-value or critical value or confidence interval, two tests that have to be tested here. Is your sample size times the hypothesized proportion greater than or equal to 5, and, I want to emphasize, and, meaning both of these, not just one of these both have to be true for you to go forward, or you can stop, you don't have a big enough sample size or something. Sample size times 1 minus the hypothesized proportion also has to be greater than or equal to 5. So I want you to think about this. Our hypothesized proportion is 8%. Our sample size is 500. 500 times 8%, well, that's 8 times 5. That's like 40 or 400. 40 something. So that's over 5. And then 1 minus 8% would be, what is that? 92% times 500? Oh my God, that's like 400 and something. So that's way over 5. So it passes both of those tests, meaning we can go forward with this problem and use hypothesis testing like this. On the quiz, you are not going to be asked to do that test. It's going to be assumed that this is true. but you need to know about this for real life. So anyway, I say to the marketing people, let's do 500, let's see what kind of response we get. In real life, by the way, we didn't really do 500, we did less than 500, and I didn't get 5% back when they're claiming and they do claim 8%, and I didn't get 5% back. I got less than 5%, so I didn't go forward with it. They were willing to for me to go forward, I said, you have to cut your price in half, and they were nowhere gonna do that. And I wasn't gonna, and I said, look, the evidence does not say you're doing 8%, so I'm not gonna spend the money. So look how much money the company saved by doing a test, doing a sampling instead of doing the whole thing. Now look, 5% is different than 8%, and the sample size is 500, which is kind of large, but it doesn't necessarily mean that it's not doing 8%. We gotta go ahead and figure this out and calculate and see if we can reject 8% or not. If we can reject 8%, then it's not doing 8%, and we start negotiating for a better price, or we don't do this advertising at all. But if we can't reject, then hey, we said to them, if it's gonna go 8%, we will go forward if it's around 8%. The significance is 5%. We lucked out. No, we didn't luck out. They lucked out because that's a really low significance. Means we gotta be so far below or away from 8% to prove our point, because we only have 5%. We only have that little 2.5% in one tail. This is two tail. 2.5% in one tail and 2.5% in the other. We can be anywhere close to 8%, and we didn't prove our point at all. We gotta be pretty far away from 8%. Now, let me set up this calculation. Ready? 0.08 times 1 minus 0.08 over 500, square root that whole thing. Put parentheses around my numerator. There we go. This will give us our test statistic. In this first example, there it is. Here's the setup. You're showing me 2 calculation details, right? Don't forget, 2 calculation details. Making sure things, appreciate that, Jake. Equals negative 2.47. There's our Z. We now have our test statistic. Let's see, this one's using critical value approach, so we're going to start with critical value approach. We don't need the test statistic to calculate the critical value. Here is our critical value formula right here. We need to know the confidence, and since this is 2 tails, we're supposed to use the confidence plus half significance. Don't forget, I hope you have this ready to go for your quiz. I have this posted where there's the key instructions, so you're making sure you're using a formula you understand and what the little instructions are. We're right here on our critical value approach, 2-tail confidence plus half significance. So, equals norm dot S I N V, parenthesis, what number goes there? Not all at once. I couldn't hear you guys just all talk at one time, and now I couldn't make out what you're saying. What's the significance or confidence on this problem? Anything, throw it to me. 95 is the confidence. This is 2-tail. What goes in the parentheses?
0.05.
No.
0.025.
No.
0.975.
There we go. 0.975. It's got to be the confident. Where am I? Right here. Confidence plus half significance. It didn't give you the confidence. It gave you the significance, but you know at 5% significance that's 95% confidence. Then half the significance, half of 5% is 2.5%, 0.975. This calculates out to, let me go back, and is our critical value there, 1.96. This equals 1.96 plus minus. There we go. I'm picturing a number line in my mind. There's a picture of one right there, but I'm picturing it in my mind. And I see positive 1.96. I see negative 1.96. And our calculation is negative 2.47. And I look at the number line and I go, oh my God, that negative 2.47 is way down below the negative 1.96, which means it's on the outside. It's on the outside. And whenever our test statistics on the outside of the critical values, we have evidence to do what? Reject. Reject. There it is. We reject it. Reject. You got to show you're compared. I would write the sentence. You know what I would write. Since our test statistic, since the test statistic is outside our confidence interval of 1 positive negative 1.96, therefore we can reject. I got to go back to the story. again, we can reject, right? We're rejecting the null, ready? We have evidence, I wanna make sure I say this right, I got scared of it. We have evidence that the response rate from our mailing could not be 8%. We have evidence to prove that a response rate from this mailing is not 8%, is different from 8%. Now we know it's lower, but this is not a one-tail, it's a two-tail. You wanna state it just the way it is in the hypothesis. So we have evidence that this mailer could not have 8% response rate. That's what it means to reject it. We've actually proved it's less than 8%, which means, hey guys, as a company, you're advertising that your response rate's 8% to try to drive business, but you're not to be believed. The test proves. Okay, how do we feel? So there's using critical value. Let's use p-value. Is that the next slide? P-value here? Yes, it is. Here's our p-value. Before we look at that slide, let's just stick to this. Look at our p-value formula. We look at our p-value formula. Is our test statistic positive or negative? Oh, it's negative. So we gotta use the no one minus in front because we have a negative test statistic, right? Is it one tail or two tail? Oh, it's two tail. Multiply by 2 if it's two tail. There we are. So we're now using equals norm dot dist parenthesis negative 2.47 comma 0 comma 1 parenthesis. We go ahead and plug that into Excel and we get, hang on, I gotta find it. Is it on here? 0.0068, 0.0068, but we multiply by 2 because we know this is a two-tail. 0.0068 times 2 ends up being 0.0136. 0.0136 is our p-value. What was our significance? 5%. Since our p-value is 0.0136 and our significance is 5%, and we're comparing them, do we reject or not reject? Let me hear you. Do we reject or not reject? Oh my gosh, you guys, you know we were recording, right? And I don't want to have to edit this. You know how long we'll take to edit? You won't even see this for days if I have to edit. So, the p-value is 0.0136. You're comparing that to the significance of 0.05. Can you reject or not reject?
We can reject.
I hear about 2 people say they would reject. Does everyone agree with that? Okay, everyone's shaking their head, but the video can't see that. Anybody else just want to mention if they reject or not reject out here? Reject, okay, we got a couple more rejects and a lot of head nodding. All right, you do reject it because 0.0136 is so far below 5% that you have to reject. Plus, we just rejected it using critical value. Are you ready for confidence interval? There's the confidence interval formula right here for proportions. The key to this is the weird part, is you gotta use sample proportion on the left-hand side. Sample proportion plus or minus. Proportion, there's no example on here, by the way. We're starting type 1 and type 2 error, talking about it on Wednesday and finishing it up on Monday. Type 2 error gets a lot of people, so. But there's no example of confidence interval, so we're gonna do it on our own. Are you ready? The sample proportion was how much? What was the sample proportion in this case? Look at the calculation up there. 0.05. 0.05 plus and minus. What was our critical Z we calculated? 1.96 times, where's our hypothesized proportion? 0.08. 0.08 times 1 minus 0.08 over sample size of 500, square root the whole thing. There's how we get our upper and lower. I did this already, so instead of recalculating everything, there's my setup. I gotta show 2 calculations. So right here, this numerator part right here, this ends up being 0.0736. Then you take that and divide by 500, 0.0736 divided by 500. I'm just trying to get this part. This equals, this is why you gotta do 4 decimals. Let me point that out. For proportions and on the homework, let me point this out. I wanna make sure you saw this at the top. See the homework? Use at least 4 digits to the right of the decimal before rounding. I'm saying at least 4. You're almost rounding too much at 4, and this is the perfect example why. We're doing just underneath the square root right now, and we're at 0.001472. If you round it to 4 digits, you're gonna get 0.001. Even though it's really close to 0.0001 and a half. Very close to it. Then I take the square root of that 0.001472, and I get 0.012133. There is the whole right side, right there. Now I multiply that times 1.96. Where am I at? Plus and minus, this is 0.05 plus and minus 1.96 times 0.012133. That gives me 0.0238. There's what I'm adding and subtracting. 0.0238. My upper interval, 0.0738, and the lower is 0.0262. Here's my lower, 0.0262. Here's my upper interval, 0.0738. Notice I win at least 4 digits, maybe 5 or 6 digits, because look how close we are to being able to reject or not reject. It's so close that if we round improperly, we might accidentally make an error here. But now is where you go back and look at the hypothesized proportion, which is 8%, and you ask, does 8% fit in the interval 0.0738, 0.0262? Everybody's shaking their head, no, no, no. It doesn't fit, therefore we must reject. You gotta show me that you're comparing the hypothesis to the interval, explain that you can reject, and then bring it back to words. Therefore, what I say, therefore we can reject. The evidence shows that the mailing did not receive 8% response rate. There it is. We proved, the evidence shows that the mailing did not receive an 8% response rate.
How do you call it margin of error, standard of error?
This is the margin of error from here over. Standard error is from there over. Remember? Yeah. But yeah, this is the margin of error ends up being 0.0238, and then we add and subtract that to the sample. The number one mistake here is accidentally using 0.8 here instead of the sample proportion, 0.05. And then to turn around and use the hypothesized over here on the right side. So you gotta be careful. All right, how did we do? You have so much information to do your homework now, but instead, I want to do another one. There's our formula from the book, right there. Sample proportion minus the hypothesized proportion times 1 minus the hypothesized over the sample size, square root the whole bottom part. There it is again, I put it in words up here. Okay, you ready? A popular weekly magazine asserts that fewer than 40% of households in the United States have changed their lifestyle because of the environmental concerns. A recent survey of 180 households finds that 67 households have made lifestyle change. They literally are giving us the hypothesized proportion, which is 40%, but then our sample ends up being 67 out of 180. We have to calculate the number of successes out of the sample size. All right, I'm erasing this. We got a whole new problem.
Is this the in-class assignment?
No. In-class assignments are always on Wednesdays. We're doing this together. We're doing this whole thing right now. All right. Making room. We're going to use 5% significance. We'll start with the p-value. Let's start with the test statistic. Help me out. Help me set this up. What's the sample proportion? What out of what again? 67 out of 180, start there. 67 out of 180 equals 0.3737. 222, I'm going 4 digits, 3722. There's that, there's our sample proportion. Our hypothesized proportion, 40%. So I'm gonna take, ready? 0.3722 minus 0.40, is that right, 40%? Over 0.40, no, 0.40, there we go, times 1 minus 0.40 over a sample size of 180?
Yeah.
180, but square root this whole thing at the bottom. There's our setup. You're showing two calculations. You got it right down here. To get our test statistic. Oh, I forgot to do the hypothesis. We're trying to prove the proportion's less than 40%, fewer than 40%, so the null would be greater than equal to 40%. It is a one-tail. What I want to do right now, though, there's our proportion, 3722. Here's our calculation, 3722 minus 40%. 40% over 1 minus equals negative 0.76. Equals negative 0.76. Wow. There is our Z test statistic. Right there. Now, if we're using the p-value approach, we'll jump right to this p-value equation. Our test statistic's negative, so we're using this one, the top one right here, because our test statistic's negative. So, equals norm dot dist parentheses negative 0.76 comma 0 comma 1 comma 1 equals. Let's do it. I don't have an Excel spreadsheet open. Hang on. Oh, are these becoming too easy? This is me talking to myself, isn't it? Here we go. Equals norm dot dist parentheses negative 0.76 comma 0 comma 1 parentheses. Now my question for you is that our p-value, or do we need to multiply it times 2? That's our p-value because it's a one-tail. So 0.2236. 0.2236. Using the p-value approach, what's the significance for this problem? 5%. Using the p-value approach, our p-value is 0.2236. Our significance 0.05. Can we reject or not reject? I hear one person can't reject. I hear another can't reject. A third cannot reject. Because our p-value is so much greater than our significance, we cannot reject. Anytime your p-value is greater than any significance, you cannot reject. All right? So now we cannot reject. Using p-value approach, let's use critical value approach. Critical value. I'm jumping down to the critical value sentence. Equals, or equation, excuse me. NORM dot S dot INV. Now, is this one tail or two tail? If it's one tail, we use confidence. If it's two tail, we use confidence plus have significance. You're telling me it's one tail because we're trying to prove less than 40%, fewer than 40%. So, if that's the case, what's the confidence that goes right here in the parentheses? 0.95, 0.95. And this equals, let's get our Z, our critical value, Z, equals NORM dot S dot IMV 0.95, you told me, because it's one tail. 1.645, 1.645 plus and minus 1.645. Let's compare our test statistic of negative 0.76, think of a number line. Our critical value is plus and minus 1.645. Can we reject or not reject?
We cannot reject.
Not reject, why?
Because it's not inside
because our test statistic negative 0.76 is inside our critical values plus and minus 1.645. Therefore, because our test statistic is inside the critical values, we cannot reject. We don't have evidence that less than 40%, we don't have evidence that less than 40%. I got to connect to the original sentence, I forgot already. I gotta go back to the original sentence. Probably assures that 40% of households in the United States change their lifestyles. We do not have evidence that fewer than 40%, we do not have evidence that fewer than 40% of households in the United States have changed their lifestyles because of environmental concerns. We couldn't reject the null hypothesis. So we don't have evidence of that. Now, confidence interval. Let me see what we have down here. They got a p-value of 0.2236, which is what we got, compared to 5%. Therefore, we cannot reject the null hypothesis. Here's the sentence. This means that the magazine's claim that fewer than 40% of households in the United States have changed their lifestyles because of environmental changes is not justified by the sample data at 5% significance level. There's the sentence. My sentence was a lot shorter than that. The whole point of the sentence is that you're going back to the original information and you're telling me whether it's true or not true, or we have evidence to, yes, that's true or not true. The original null hypothesis, or the original sentence at the beginning of the story almost. Confidence interval, though, that we don't have that on here on this answer, but we're going to do it. There it is. I just want to set it up. We know it's not reject because all of these have been not reject, but let's do the setup. You guys, someone back there in the back, somebody near the back who's not answering any of my questions, to please help me set up the confidence interval approach using the information from this problem right here. What will be the first number? Anybody back there? Anybody want to help? The first number, the sample proportion.
0.372.
There we go, 0.3722 plus and minus, what is the critical value?
0.76.
No, that's the test statistic. The critical value we calculated. There it is, 1.645 times, and now I go this giant square roots here. What is our hypothesized proportion? 0.40 times 1 minus 0.40 over, what's our sample size? How many? 180 square root. There's the setup. Now, if we calculated all of this, we would have an upper and lower interval. My question for you is, are you ready? My question for you, when we add and subtract to this 0.3722, a little over 37%, will 40% fit inside that upper and lower range? If I were to calculate this out and get that upper and lower interval range, is our hypothesized 40% going to fit between it or not fit between it? We already know the answer. What is it going to do? It's going to fit between it, because we couldn't reject it using p-value, we couldn't reject it using critical value, and we know that if the hypothesized proportion fits between the upper and lower, we can't reject it. And of course this is going to turn out the same as a not reject. So if we calculate this all out and get the upper and lower, 0.40 is going to be somewhere between them. You just saw two examples now using each approach. So I want to now read the homework to you, see if you feel like you have any questions of the homework based on those two examples. And we have time for one more example if we want to do it, or we can get out early. I don't know. Let me just read these real quick. Here we go. Use at least 4 digits to the right of the decimal before rounding. Number 1, in order to test the population proportion is greater than 0.38. Uh-oh, is this one tail or two tails? This is homework. I don't even know why I'm asking that. Hey, now you speak up. Now you guys speak up. Forget it.
One tail.
You draw a random sample of 100 observations and obtain a sample proportion of 45%. Give the hypothesis, show your details solving manually, including an Excel equation for either your p-value or your critical value, and explain if you can reject or not reject using 10% significance and the p-value approach. Everybody know what to do here? It would be just like the first way we started this one. Number 2, an article states 14% of American households are having to borrow from their retirement accounts. You want to test to see if the percentage is now being exceeded. Don't say it yet, just think to yourself whether it's on one tail or two. Don't say it out loud, whether it's one tail or two tail. A random survey of 200 American households with retirement plans, and it resulted in 37 of them borrowing against the retirement program. Give the hypothesis, show your detail solving manually, include an Excel equation for either your p-value or critical value, and explain if you can reject or not reject at 5% significance in using the critical value approach. Then, give a final sentence to explain the meaning. So number 2 is asking for that final sentence. Number 1 didn't. Number 2 did though. And number 2 is using the critical value approach. Number 1's the p-value approach. Everyone imagining what they got to do there. Okay? Number 3, this is too easy. This quiz is going to be so easy, isn't it? I'm going to have to throw some tricks in there. Just going to be too easy. There's only 3 questions on this homework, is that true? Oh, man, I'm in pain. A recent article stated that 80% of American drivers have texted while driving in the past year. In order to test if the proportion has changed, think about it. In order to test if the proportion has changed, don't say it out loud. 1 tail, 2 tail, don't say it out loud. You draw a random sample of 60 observations and obtain a sample proportion of 72%. That is less than 80, isn't it? Give the hypothesis, show details solving manually, include an Excel equation for either the p-value or the critical value, explain if you can reject or not reject using 5% significance and the confidence interval approach, then give a final sentence to explain what it means. Explain the meaning. How do we feel? Oh my gosh, you guys, this homework's too easy. I just did it all in my head while I was reading it. Oh, God. All right, I'll see you on Wednesday. Anybody who didn't get things that I'm handing back, please come up and grab it real quick on your way out. Anybody who forgot to sign in, please sign in.